Lesson 5.4 is solving compound inequalities. Up to this point, you've solved some multi-step inequalities, but now we're going to go ahead and solve what are known as compound inequalities. And a compound inequality consists of two separate inequalities, but they're joined by the word and or the word or. And you treat them entirely different if it's an and or an or. So we're first going to look at the ands. The graph of a compound inequality with and is called the intersection of the graphs of the inequalities. So here we have x is greater than -2, and then remember it's an open circle shaded to the right, and we have x is less than or equal to 1. So we have a closed circle, it shows ownership, and it's shaded to the left. So we can say right here that -2 is less than x. Right up here we could flip it around. We could go -2 is less than x. Notice that the mouth is still eating the x, so we're just flipping it around. And x is less than or equal to -1. When we graph those, they intersect, they run into each other, and this is how we actually write the inequality. -2 is less than x is less than or equal to -1. When you do this, you always write, and make sure you write this down, is the smaller number less than the variable less than the larger number. We're always going to turn these into less thans or less than or equal to, depending on what the inequality has. So that is an intersection, which will have, sometimes it'll have the word and, sometimes it will just be in this particular form, and you're going to have to recognize that it's an and. Next we have another compound inequality, and this is the word or, and this is called the union of the graphs of the inequalities. So here we have x is greater than or equal to 0, so closed circle shaded to the right. We also have x is less than -1, open circle shaded to the left. It can't be both with the way that this is written. So we're saying x is less than -1 or x is greater than or equal to 0. So in this case, the inequalities are shaded away from each other. They do not intersect. This is called a union. All right, let's look at some of these verbal phrases. We're going to translate these verbal phrases into an inequality, then we're going to graph it. So we're looking at all real numbers that are less than -1 or greater than or equal to 4. So this is a union. So all real numbers, we're just going to use the variable x, that are less than -1 or those real numbers are greater than or equal to 4. So I'll just go ahead and put my numbers on here. I have a -1, and in this case x is less than -1. Oops, I don't know why I put a 4 there. -1, or x is greater than or equal to 4. And there it is. There's my union. Here we have all real numbers that are greater than or equal to -3 and less than 5. So this is an intersection, and I know it's the smaller number. So it says greater than or equal to. So I do have to put the less than sign though, so you do have to flip it. Remember, smaller number less than. In this case is less than or equal to, and less than 5. So I have to go from -3, so here's 0, to 5. 1, 2, 3, 4, 5. So -3 gets the closed circle, 5 gets the open circle, and we're shading right between them. It's okay if you want to do this on the actual graph. That's the way that it was shown in the example, and it's okay with me if you do it above. You're going to see it done both ways. Some teachers will only accept it on the graph, so just make sure that you know who your audience is. Alright, so here's a real world situation. A crane sits on top of a camera car and faces towards the front. The crane's maximum height and minimum height above the ground are shown. Write and graph a compound inequality that describes the possible heights of the crane. So it looks like this crane can go anywhere from 4 feet to 18 feet, and any distance in between. So that would be an and. So we're going to go 4 is less than or equal to x is less than or equal to 18. So I'm going to go in steps of 2. Actually, you know what? I don't even need to start with 0 there because it's positive 4. So 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. And these are both closed circles. So we put one on the 4, we put one on the 18, and we shade in between. So the height of the crane can be any of these distances from 4 to 18 feet. Next, we're going to go ahead and solve these compound inequalities. This is with an and. I know it's with an and because of the way that it's written. It's small number less than the variable terms and then less than the other constant. The nice thing about these is you can solve them in sort of one fell swoop. I want to get the x by itself, so I'm going to subtract 5, but I'm going to subtract 5 on both sides of the inequalities. So 2 subtract 5 is negative 3 is less than x, and 9 minus 5 is 4. So my answer is negative 3 is less than x is less than 4. So I have to go from a negative 3 to a positive 4. And these both have open circles, and I'm shading in between. Here I have a couple more ands. So I'm going to first subtract the 4. So this is a two-step inequality. I get 6 is less than or equal to 2y is less than or equal to 20. Divide all terms by 2. And I get 3 is less than or equal to y is less than or equal to 10. And when I graph that one, I have to go from 3 to 10. So 3, 4, 5, 6, 7, 8, 9, 10. And both of these also have closed circles. All right, number 6. I'll add 1. So I end up with negative 6 is less than negative z is less than 4. Now I have to divide by negative 1. And recall before, when you divide, you have to flip the sign. So this is 6 is greater than z is greater than negative 4. However, recall that the proper way to write a compound inequality is smaller number, less than variable, less than larger number. And it works. If I flip this all around, I had to flip the inequality signs. So I have to graph from negative 4. So negative 3, 2, 1, 0, 1, 2, 3, 4, 5, 6. And these both have open circles. Now we'll graph with an OR. With an OR, you simply solve them separately. So 2x plus 3 is less than 9. We just subtract the 3. 2x is less than 6. Divide by 2. X is less than 3. Or 3x minus 6 is greater than 12. I'll add the 6. So 3x is greater than 18. Divide by 3. X is greater than 6. And it's imperative that you put the word or in your final solution. So I have to go 3, 4, 5, 6. And in this case, I shade the 3 to the left and the 6 to the right. Let's try another one. I will subtract 1. So 4c is less than or equal to negative 4. Divide by 4. C is less than or equal to negative 1. Notice, even though my answer is negative, you don't flip the inequality unless you're dividing or multiplying by the negative. And here I'll add the 3. So 5c is greater than 20. When I divide by 5, I get c is greater than 4. And again, don't forget your OR. So let's go negative 2, negative 1, 0, 1, 2, 3, 4. You don't really need the negative 2. I'll do a closed circle, shaded to the left, and an open circle, shaded to the right. Last one. The Mars exploration rovers Opportunity and Spirit are robots that were sent to Mars in 2003 in order to gather geological data about the planet. The temperature at the landing sites of the robots can range anywhere from negative 100 degrees Celsius to 0 degrees Celsius. Write a compound inequality that describes the possible temperatures in degrees Fahrenheit at a landing site. And they're asking us to use this formula. So it can go from negative 100 degrees Celsius, so 5/9 F minus 32, to 0 degrees. So we do the small and then we have the large. So the first thing I want to do actually is multiply both sides of this, or actually all three parts of this, by 9/5. I do not want to distribute the 5/9 because I don't really want to create more fractions if I don't have to. So when I do that, it unlocks the parentheses. Here I still get a 0. And 5 divides into negative 100 negative 20 times. 9 times negative 20 is negative 180. Now I'll go ahead and add 32. And I get negative 148 degrees is less than or equal to F is less than or equal to 32 degrees. And this is in degrees Fahrenheit, so we converted them. All right, so let's go ahead and graph this. We have to go from a negative 148, why do I forget my 1, up to a positive 32. And in here, we're just going to put these values on here. So I've got a closed circle, and I'll shade in between. And it's asking for 3 possible temperatures. So one possible temperature is negative 120 degrees Fahrenheit. Another one is 20 degrees Fahrenheit. And another one is negative 110 degrees Fahrenheit. Any temperatures between here are possibilities. Okay, that is it. Here is your assignment. I believe I did put it on top of your notes already though, so you should be good to go. And the assignment, you have all hour tomorrow to work on it, but if you'd like to start it ahead of time, that's okay.